The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so for number one, we're given a function, in this case y equals negative tan, and we have a couple of interesting things here about this function. There's a lot of translations done here. So we reflected about the x-axis upside down vertically because we have a negative sign outside. We have pi over 2x minus pi over 2. So we have some sort of shift here as well as a horizontal compression. So the first thing that you have to find is the period. Well, first what you need to know is what is the period of tangent regularly. The regular period of tangent is pi. And remember that the new period of something that's been stretched or compressed is the original period divided by the coefficient that's in front of the x. So our period is going to be pi, normal period of tangent, divided by pi over 2. Pi divided by pi over 2 then would just be 2. So that's going to be our period. And then the next part is 2 consecutive vertical asymptotes. So when you want 2 consecutive vertical asymptotes, first of all think about where does tangent normally have vertical asymptotes. It normally has vertical asymptotes at every multiple of every odd multiple of pi over 2. So we need the inside to also equal multiples, or the odd multiples of pi over 2. So we want this inside part to equal things like pi over 2, negative pi over 2, 3 pi over 2, things like that. That's where we would normally have vertical asymptotes for tangent. However, it is a little bit simpler than that because since you already found the period, you only have to find one of them because then every other one is just going to be the period length away. The easiest one to see, most likely here, would be if x is equal to 0. Because if you plug in 0 for x, this whole part 0, you just get negative pi over 2. Tangent of negative pi over 2 is definitely undefined. So that is a vertical asymptote. So we have vertical asymptotes at x equals 0. And then the next one just has to be the period away. Well, the period's 2, so the next one would be 2. Remember that on a tangent graph, your vertical asymptotes are always just a period's length between each one. So as soon as you find one of them, you know all the rest of them, if you already know the period. Because we could go in either direction. So we have 0, 2, 4, or we could go negative 2, negative 4, all of those. So for number 3, the key points in one period. So the key points for a tangent graph, in this case, you usually would just do 2 different periods, I suppose. So let's figure out what these are here. In a we do one period, break it into 5 points. So in one period, we go from 0 to 2. So we want what happens at 1, what happens at 1/2, what happens at 3/2, all equal intervals. So we're going to have our key points of 0, 1/2, 1, 3/2, 2. So these 5 points are breaking our interval, our one period, down equally. So what we want to do is, what are the y's? So let me just kind of make this chart here, kind of like what you have on the paper. So what are the y's for this? Well, x equals 0, well, is the vertical asymptote. So this is undefined. So it was the same for x equals 2, because that was also a vertical asymptote. So let's see what happens when we plug in these other numbers. Let's just start with 1 because that would be the easiest. If we plug in 1 for x, we get pi over 2 minus pi over 2. That's 0, and tangent of 0 is 0. So we get that that's 0. So now the last things we need to do are just 1/2 and 3/2. When we plug in 1/2, we get pi over 4 minus pi over 2. So let me write that out here. So we get pi over 2 times 1/2 minus pi over 2. So this is tangent of pi over 4 minus pi over 2. If you convert to a common denominator of 4 and subtract there, we get tan of negative pi over 4. Oh, sorry, these should all be negative out here too because our function was negative tangent of that. And remember that tangent is an odd function. That's one of our other pieces of information we use throughout this course. So tangent of a negative angle is the same thing as negative tangent. And since it's already negative, this is actually just the same thing as tangent of pi over 4. Tangent of pi over 4, that's one of our common angles. You should know that that's equal to 1. So we get 1 there. And the last thing is going to be 3/2, but keep in mind, all of your trig functions over one period show symmetry. So you should expect that this should be -1. Because remember, tangent, the basic shape, looks like that. It's an odd function, meaning everything that happens here, the opposite happens on this side. And even if you flipped it upside down like we have here, now it's this way, still, everything that happens on this side is upside down for the other side. 0 was right in the middle, so that is why that's in the middle. So by thinking about it like that, you can save yourself some work and not have to plug in 3/2 and do this whole process again. This is going to have to be -1. So here we have all of our points there. So the last thing is to just graph it. So let me do that over here. And this is going to be the case anytime you get one of these problems in this class, is that they want you to include at least 2 full periods. Alright, so we know we have a vertical asymptote at 0. That's part of what we found before. It's undefined here. We know we have a vertical asymptote at 2. So this is one period. To get another period, let's just go backwards to -2 because it should look the exact same on this side. So now, as long as we draw the correct graph in here, we have 2 full periods. So, at 1, right in the middle, we hit 0. That must mean on the middle of this one, -1, we hit 0. At 1/2, we hit 1. At 3/2, we hit -1. So that must be the same analog for this side. So you can already see, since this is going to be an upside down tangent graph, you should basically know that the shape is going to be like this, because it's our normal tangent graph just flipped upside down. So this is going to have to look like that. So what's important when you do this on the exam is just that you label all the key points correctly, and you touched all of the key points when you're drawing your graph. As long as that's fine, you're going to get full credit for it. It doesn't have to be perfect in terms of shape and all of that. So we have asymptotes here, so you know it has to approach them from either going to infinity or going to -infinity, and because the shape had to be this way, this is the only way this graph could exist.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.